A warm good morning to all. Myself GAYATHRI Krishna from Amrita Vishwavidyapitham Mysuru campus. I am currently pursuing my masters in chemistry. Right now I am in second year of PG and I have taken the category NEET chemistry for the test of an academy. So here I am going to present the chapter chemical bonding and molecular structure. It's a very big chapter, so I am only going to focus on one topic, which is ionization energy. So let's get into the video. So I want to explain what is ionization energy and the factors affecting ionization energy. So what is ionization energy? I have given the definition here. It is the amount of energy required to remove an electron from the outermost shell of an isolated, gaseous or neutral atom. Let's take this atom as an example. This is an atom. Here you can see there is an N here in the center. N means it's a nucleus. Around the nucleus there are different shells. First shell, second shell, third shell. And this in all these shells there are variety number of electrons are present. So what it is? Ionization energy is an energy for what? To remove an electron from the outermost shell. So in this atom, which is the outermost shell, it is having only three shells. So this is the first, second and third. This is the outermost shell. So in outermost shell there is only one electron. So we have to remove this particular electron. For that we need that energy. So this is the energy required to remove an electron from the outermost shell. Okay. And there are two more conditions, which is isolated, gaseous or neutral atom. This atom should be isolated, gaseous or neutral. So what is isolated? We are very familiar with the word isolated. Like in the case of COVID pandemic, like if one person was infected, we used to isolate that person. Just like that. So isolation means we will put that person in particular room and that person should not come in contact with any other person. So just like that, the atom should be isolated. Isolated means just take A as atom. Like near this atom there should not be any other atoms or molecules or ions. And this atom should not be in contact with any other atoms, or it should not be in reaction with any other atom. That means this atom should stand alone. Okay, that means isolated. So this atom should be isolated. So if this atom is A, it should be isolated. And the next condition is it should be gaseous in state. So we can write A is in gaseous state. Okay. So this is the atom which is isolated. It's in gaseous state. So from this atom, this is the outermost shell. We have to remove this electron. For removing this electron, we have to give energy. Okay. So that energy is known as ionization energy. So like this nucleus is having positive charge. So we can write a positive charge in the center. And this electrons we already know it is having negative charge. So we can represent it as by E negative or E minus. So it is obvious that there is an attraction between the positive charge and negative charge. So what will happen? This nucleus will attract this electron towards itself. So we can write, we can draw like this. There's an attraction towards this nucleus. Okay, there's an attraction between this nucleus and this electron. So in ionization energy, what we have to do? We have to remove this electron, right? So we have to break this bond. We have to break this attraction between this nucleus and this electron. I hope everybody is understanding. We have to remove this. We have to break this bond. We have to break this attraction between the nucleus and electron. So that's what ionization energy. I hope everybody understood. So let's get into the factors that is affecting ionization energy. The first one is size. How size is affecting ionization energy? So in this atom, we can see, for example, I will explain how size is affecting ionization energy. If I am standing right next to a speaker or right next to a mic, I can hear everything very clearly. And if I am moving away from the mic or speaker, the sound will not be that much clear. Just like that, if the electron is moving away from the nucleus, the attraction between the nucleus and electron will be less. It will decrease. If consider this positive charge, this nucleus as mic and electron as person. So in the first shell, the charge, the attraction will be greater. As the person moving away from the speaker, he cannot hear everything clearly. Just like that, as the electron moving away from the shell, nucleus, the amount of energy to kick this electron out of this shell, right? So ionization energy is less. Okay, so we can write. As the size increases. I am writing size as S. As the size increases, distance between nucleus and electron increases. I am writing D. Distance also increases. Distance increases means attraction between the nucleus and electron will decrease. That means I can write A. A decreases. A decreases means we only have to give very less amount of energy. That means ionization energy also decreases. I am writing ionization energy in the short form IE. IE, what will happen? IE decreases. So size increases, distance between nucleus and electron increases, like attraction between the nucleus and electron will decrease, and ionization energy will decrease. Right? So we can write ionization energy is directly proportional to 1 by size, or ionization energy is inversely proportional to size. So as the size increases, what will happen? Ionization energy decreases. We only have to give very less amount of energy to remove this electron. So we know that in periodic table, we know as we move down the group, it is like this. The size is increasing, right? As we move along the period, the size is decreasing, right? This is how periodic table is arranged, right? So as we move down the group, what will happen? Ionization energy, size increases, attraction decreases, ionization energy will decreases. So ionization energy decreases. But what will happen here? As we move along the period, what will happen? Like the electrons are very much more close to the nucleus. Much more close means the attraction between the nucleus and these electrons are very much higher. So we have to give more energy to break this attraction, to remove an electron. So IE is great. Okay. In the case of periodic table. So size is inversely proportional to ionization energy. Next one is nuclear charge. So what is nuclear charge? Nuclear charge means the charge of this nucleus. Charge of this nucleus means, I already told you, nucleus is positively charged. That means it contains protons. So as the number of protons in this nucleus increases, nuclear charge also increases. Nuclear charge increases means it is having more power to attract the electrons towards itself. So this nucleus can attract this electron more powerfully. That means attraction between the nucleus and these electrons is higher. If the attraction is higher, ionization energy is also higher. We need more ionization energy to break the bond. To break the, not bond, break the attraction between the nucleus and electrons. So we can write nuclear charge. We can write ionization energy. IE is directly proportional to what? Nuclear charge. The first one, size is inversely proportional. Nuclear charge is directly proportional. So the third one. The third one is electronic configuration. So I already told you in the case of periodic table, as we move along the period, what will happen? The size will decrease and ionization energy is increases. So let's take a period, the carbon oxygen period. So carbon, nitrogen, oxygen, just like that. So in size is decreasing as we move along this period. So carbon is having more size than nitrogen than oxygen. So by this IE theory, we study that oxygen is having more IE than nitrogen than carbon. As we move along the period, IE is increasing. So oxygen is having more IE than nitrogen than carbon. But this is not true. Actually, nitrogen is having more ionization energy because of ionization energy. Nitrogen is having more ionization energy than oxygen. Why it is so? Let's take nitrogen. Nitrogen is having atomic number 7. 7 means 1 takes 2, 2 is 2, outermost subshell. In the case of oxygen, 2p4 is the outermost subshell. We know that p subshell can accommodate maximum number of 6 electrons, right? So if it was 2p6, it is like fully filled configuration, right? Fully filled configuration is more stable. But here 2p3 means we can write like this. Like I am only writing the last shell like this. In the case of oxygen, it is like this. Last electronic configuration. Okay, so this is 2p3 and 2p4. 2p3 means half filled configuration, whereas 2p4 is not half filled, it is partially filled. So half filled configuration and fully filled configuration are exceptionally stable. So that is why nitrogen is more stable. Like in nitrogen it is like this. It is 2p3. It is half filled configuration. It is having more symmetry and the exchange of energy is more in nitrogen. So it is half filled configuration. That is why it is more stable. More stable means we have to give more energy to remove one particular electron from nitrogen. To become 2p3, we have to give more energy than oxygen, because half filled configuration we can write half filled and fully filled configurations are stable, exceptionally stable. So if you are taking an example, let's take 3d3, 3d7, 3d5, 3d10. We know that these subshell can accommodate maximum number of 10 electrons. So this 3d10 is fully filled configuration. It is more stable. Just like that, 3d5 also. 3d5 means it is half filled. Just the half of 10. So it is also more stable. Okay. So 3d10 and 3d5 configurations are more stable. It is half filled and fully filled configuration. So that is how electronic configuration. So the next one is shielding effect. So what is shielding effect? From that word itself, it is explaining what is shielding effect. So I told you this is a nucleus and there are various electrons in each shell. So there is an attraction between this nucleus and this particular electron. So like before this valence electron means the last electron. Like the electron in the last shell is known as valence electron. So here in this case, this is the valence electron. So before that there will be various electrons. And we know that the electron is having negatively charged. So what will happen? All these electrons, there will be a repulsion. Repulsion means like opposite charges, like same charges that will repel each other. All these are like negatively charged. These charges will repel each other. Like there will be a repulsion between all these electrons. So what will happen? This I told you this attraction between nucleus and this electron. So before this electron, there are many shells. And what will happen? This shell and its nucleus will act as a shield or screen. Just like a screen. So this last valence electron will get like very less nuclear charge. Okay. So the attraction between the nucleus and this valence electron will be very less due to the inner electrons or inner like shells. This is called screening effect or shielding effect. Due to the screening or shielding effect and due to this repulsion, this will like these electrons, due to this repulsion, this electron will try to push this electron out of this shell. So due to screening effect, the attraction between the last electron, that is valence electron and this nucleus will be very less. That means we can easily kick this electron out of the system. That means ionization energy is very less. So as the screening effect or shielding effect increases, ionization energy is decreasing. So as the number of shells before this particular valence electron and as the number of electrons before this valence electron increases, screening effect or shielding effect increases. That means ionization energy increases. Ionization energy decreases. shielding effect. So these are the factors that is affecting the ionization energy. I hope everybody understood. So I am going to summarize the topic that we have discussed in this video. So first I will discuss what is ionization energy. It is the energy required to remove an electron from the outermost shell of a gaseous, isolated or neutral atom. So there are 4 conditions. It is very important. And we have discussed about the factors affecting ionization energy. First one, size. What will happen? Size, ionization energy is directly proportional to 1 by size, so inversely proportional to size. Next one, nuclear charge. Nuclear charge I am writing NC. So ionization energy directly proportional to NC, nuclear charge. The third one, electronic configuration. I told you about nitrogen and oxygen. There are many more examples. So half-filled and fully-filled. Half-filled, fully-filled. We can write as example 2p3, 2p6. More stable. More stable means like ionization energy is more. Okay. Next one is shielding effect. So as the shielding effect increases, ionization energy decreases. So it is inversely proportional. So I hope everybody understood. These are the one of the important topic that in the first chapter of +1 or in the first chapter of +1, that is ionic bonding and molecular structure. Thank you.